Hello class, today we will start a new chapter and the name of the chapter is data structure, right? It is a bit conceptual thing, so from the very beginning pay attention and read the notes very carefully which I will provide you. Now, what do you mean to say by data structure? In this chapter basically we will discuss various kinds of data that we will get to handle. Now you have already used some basic data types like integer type, float type, boolean type, character type and all this, right? So basically if we see this way, that what are available with the Java library, what is provided to you with Java interpreter are basically this one. You can see I wrote primitive or inbuilt data type and user defined or compound data type. Primitive means which is provided to you with the Java interpreter and which you have already used in class 11 and part of class 12, like integer type, float type, boolean type you are very comfortable with. In fact, you have clubbed this data together to make a list, to make a tuple, to make a dictionary, and one more type is there which is not there in your syllabus, that is set. So all these types basically you have handled, and the rules related to all this data, how to make use of them, and there are various other constraints and various other conditions that are already mentioned under the Java interpreter. So you just follow the rules, make use of them and get the benefit of it. For example, if I have a tuple, if I declare a tuple, there are some functions available. I can make use of those functions to get various things done. But there is another kind of data which is called user defined data type. That means this kind of data is not mentioned in the Java interpreter. Nothing is given there. So what you have to do is you have to make use of all these things and you have to follow some rules and create a data to serve your own purpose. You are facing a problem, you are solving a problem, and to solve the problem you felt that these all data which are given in Java interpreter are not good enough. So you have the liberty to create a data type of your own. But yes, you have to follow some rules for that also. Okay. Now in user defined data type, it is called either user defined data type or some people call it compound data type. Similarly here also you can call it primitive data type or you can call it inbuilt data type. Inbuilt data type means that is already there with the Java interpreter. And these are called user defined or compound. Now in this you will find two subcategories. One is called linear, another is called non-linear. This non-linear part is not there in your syllabus much. I was going through it. You just remember that non-linear data type under the compound data type or user different data type. Two examples are, one is called tree, another is called graph. Tree type and graph type. These are the two non-linear data type. But mostly what we have to do is we have to learn this part of the data structure, that is the linear data structure. Fine. Under this we will first see arrays, then we will come to stacks and queues, and linked list is not there, the part of your syllabus. So basically we will have to do these arrays, stacks and queues very thoroughly. Now when we come to arrays, what is it? Arrays are basically, if you remember in class 11 we have done list. Okay, arrays are nothing but list. Very specifically it is called a linear list. Okay, in a list, if you remember, we had the liberty of putting data types like this. I am erasing this part. You have the liberty of storing dissimilar data type also, like you could easily write 20 and immediately after that a value like this, immediately after that another value like this. This is the list of values. But when we talk about arrays is a list, but there the data type will be all of similar kind. All will be of homogeneous data. All will be homogeneous data. That means they will be all of same type. For example, if I take another list P and if we write 10, 20, 30, 40, so we can see here every element present in the list are of same type. So then we can call it an array. Array is basically nothing but a collection of some data element put together. Okay, conceptually that is an array, and in Python when we talk about arrays, it is nothing but list having similar kind of data items. Now in class 11 we just touched it up that arrays, like this kind of arrays, it is called a single dimension arrays because it has only one way of is expanding only in one direction. And we have learned that this is in the index position 1, this is in the index position 0, 1, 2, 3, etc. But if we like draw it in a diagram, how will it look like? It will look like this. That means we can also represent an array to explain things this way also, like 10, 20, 30, 40. They are stored in different cells of the memory. Like if I imagine that these 4 cells are taken out from the RAM, okay, then these elements are getting stored in the consecutive cells, right? So we can say this is in the group of cells which are taken out to store this. In that group, 0, 1, 2, 3, these are the index positions. So in this case, we will call it a single dimension array. But it is also possible to have an array like this. What is it? It is like if you have some data stored this way. For example, I have like this. Okay. So I stored some elements, for example 5, 9, 6, 10, 12, 3, 4, 8, 9, some elements I stored. But all the elements are of same type. But in this we can see that we have a length and we have a breadth. So if we have a situation like this of a group of items which are stored in a memory location where we can think of a length and a breadth, then this group of reservation, then this group of cells which I have taken out from RAM to reserve this, to store these numbers, it can be called a double dimension array because it has 2 dimensions, length and the breadth. Fine. Now you might be wondering that if a structure is like this, then how can we store it? In class 11 we have just touched it up. It is nothing but to be represented in Python with the help of nested list. Like in this case, for example, if P is my list, I can always write my first, look at this, I can imagine that this is a list, this itself is a list, and this is also a list. So it is a combination of 3 lists together. So I can write 5, 9, 6, I can write 10, 12, 3, and I can also write here 4, 8 and 9. So if we take a list like this, then that will be able to represent an array, a double dimension array, the way I have drawn. Now when we talk about a double dimension array, we have to remember that these horizontal lines, these are called rows. So I can say this is my row number 0, this is my row number 1, and this one is my row number 2. Similarly, these vertical groupings, this can be called column 0, we can call it column 1 and column 2. So now what will happen? If I have to identify every element present in it, I can follow a kind of system, kind of indexing. Now here obviously just mentioning one number will not be good enough to represent an element present in the double dimension array. So what we need to do is, for example, if I have to refer to this, so he is present in the row position 0 and in the column position 1. So I can say that this can be represented by P. First I will write the index of row and then we will write the index of column. So if we write P01, I shall be able to represent this. Similarly, if I take this one, how can I represent it? We will be able to represent it easily by writing P. Again, row position first, row is 1, so we will write row 1 and we will write column number 2. So this is how we can represent every element present in a double dimension array. So that means if I have stored a double dimension array, just like the way I have shown you, then it is possible for us to access them also different ways. It is possible to print them exactly the way I have drawn, and various other things we can do with this. So we will now see in our next video how we can input this kind of list. Okay, one very simple way of doing is by eval you can do it, but if you want to do it in a guided manner, for example, I have given you this diagram. Okay, so you want to guide user at every step how it is to be input, like which element to come in 0, 0 cell. This is 0, 0, this is 0, 1, this is 0, 2. Then you can write the input part of the code in a little structured manner, which I will show you in my next video. So up to this much is clear to you. You don't have to remember all these things. I erased it, but it will be available in your notes. Please read the notes very carefully. Fine.